Hey there. So, thinking what we have made today. So, this is a very simple project. So, here we have used SW420 vibration sensor, which is also known as a shock sensor. So, and here, unlike every time, we have used a buzzer module. So, this needs to be connected with Arduino in in some different form. So let us know what exactly this is. So this here is a SW420 vibration sensor or a shock sensor, as I have told you. So as we can see that we have a module here, a sensor module, inside which there will be a coil. When it will, um, shake while we shake the sensor, the coil will say that it is vibrated or it is shaken. And whenever there is a vibration, the buzzer will give us alarm. So this is what we have made today. So let us start to build this. So in very easy form, I'll just tell you the connections. So like every sensor we have is you know a naught, D naught, ground, and VCC in our vibration sensor. So A naught is for analog, signals, and D naught is for digital signals, and VCC and ground are power pins. So I'm using D naught with pin number 2 of the Arduino Uno, and the ground for the ground, and the VCC for 3.3 volts, because here we can see that I'm using buzzer module also. So buzzer can only work on 5 volts of the current, but the sensor can work on 3.3 volts. So I'm using 3.3 volts for the sensor, and 5 volts for the buzzer. So let us start to make the uh, this project. So the connections are as shown in the circuit diagram. Yeah, so as we have seen the circuit diagram, so let us start with the connections. So all we need is an Arduino Uno and an SW420 sensor module and a buzzer with some jumper wires and a connector with a PC. So let us start to make the connections. So first I will take the SW420 sensor and connect D note output, D note and ground and VCC to the Arduino. So how are we connecting it? I have told you, like the VCC will be going to the 3.3 volts of the Arduino, and the ground will be going to the ground of the Arduino, and the D naught pin of the sensor module will be going to the pin number 2 of the Arduino's digital pins. So the pin number 2 here. Yeah. So our sensor is ready. Now I will same way I'll take a buzzer module. I will connect all these 3 pins of the buzzer, and I'll connect the VCC to the 5 volts of the Arduino. Yeah, here the 5 volts of the Arduino is connected to the buzzer, and the ground of the buzzer I'll connect to the other ground here. In Arduino we have 3 grounds, so 2 are here and 1 ground is in digital pins. So and the output pin of the buzzer module will be connected to the pin number 8. So here we can take anything in our project. So why 8? So let me explain you. So these pins from a receiving pin, that is 0 to 7, these will be used for input and output of the sensors or actuators which will be using, and from 8 to ground will be used for the output pins. So if we use in this form, it will be easy for us to make the project. And the receiving and transmitting pins are used in projects where we want to receive or transmit signals like Wi-Fi module or Bluetooth, etc. So now I will just connect the Arduino and power it on. So when I power on, we can see that the sensor is working perfectly and all the connections are done. So I have removed the code from this Arduino, and let us see the coding part, and we will insert the code. Yeah, so as we have seen the circuit diagram, let us see the code. So now this is a very simple code here. So in this we need not install any libraries or anything like that. So all we need to tell is input pins and pin modes and some commands for our sensor and the buzzer. So the input pins will always be the digital pins or analog pin. So analog pin will be used when there is a naught or a naught of the sensors will be using. So Arduino will give the power even if you don't give the command for the Arduino. So if we want to delay something, then we will add delay. So sensor pin will be on pin number 2, and the buzzer pin will be on pin number 8. So and the pin modes, the sensor pin will be input and buzzer pin will be output. Sorry, I have brought this buzzer to the right side. Yeah, so the buzzer pin will be 8 and sensor pin will be 2, and the pin sensor pin will be the input, that is pin number 2, and the buzzer pin will be output, that is pin number 8. And as we can see that we are using serial monitor here, that is serial print. So we need to set a communication rate which is 9600 bones. And if the digital read sensor pin will be high, then the buzzer should be low. Sometimes buzzer will have a glitch. If you tell that to be low, then it will be high because of some connections internally. So that is nothing to worry. So we will just change the command. So I'm telling here the low means high and high means low here. I'll just low means high, and here the high means low. High means low. Okay. So I hope you have understood this. And now the serial print. Whenever there is high from the sensor, that is whenever the sensor will sense any vibration or anything, then we will write vibration detected. So this part here can be written as our wish, like in this brackets we can even leave it empty or we can make it 0 on something like that, but I'm using vibration detected. And here if there is no vibration, in only if this state is there, other than that no matter what it is, so that is what we are using else. And buzzer pin will be high, that means the low, because my buzzer here is misconnected. And serial print will be safe, that means like in serial monitor it will be written as safe. So now let us select the board, that is Arduino Uno, and will verify this. So as we can see that there are no errors in our program. And now what we will be doing is we have already selected, I'll just upload the code to our Arduino. And after uploading the code, we'll just open the serial monitor and we will wait for to sensor to work. As we can see that there is no vibration, so it is coming as safe. So when I shake the sensor, we can see that there is vibration detected. So here this is going too fast because we have not given any delays here, and it will be sensing every microseconds. So as we can see that we whenever we are shaking the sensor, the vibration detected um, messages in the serial monitor. So this is how we make the code and we communicate with the uh, sensor. And here we can see that serial plotter. So here what will happen is we will be we can see that there is some numbers here which is just going on as our sensors state. So this is nothing similar to the serial monitor. So here it will be in numerical form, here it will be in the word form. So if I stop here, then everything will be stopped. So these are the timings and these are the rates of that vibration values. So this is 4630 bounds, 4642, like that. And here we can set the bound rate. From it starts from 300 and it can go to 20 million. So this is how we make this, and when I run this, it will just start to calculate those amounts. So we will be learning about this in upcoming videos, and now we will see the physical output, that is how our circuit and the project is working. So that this is how we learn to code our project. So let us see the output. Yeah, so as we have seen how to make the connections, and we have understood the plotting of serial monitors and all. So now let us see how it is working. So we have made the connections and everything, and now we can see that whenever I'm shaking the sensor, like it is sensing any vibration on the sensor, the buzzer is giving us the alarm. So now we have successfully made the vibration alarm system. So now the question is, where exactly this project can be used. So this project we can use in something like measuring earthquakes. Like whenever there are earthquakes, the sensor will be sensing those values and giving us the alarm. And we can use it in safety systems of vehicle, like whenever there is crash bit above some threshold amount of vibration, then the airbags will be open. So these and the something like this in safety measurements. So these are the applications of this module. So now we have successfully made the vibration sensor module, that is vibrating alarm. And we have also learned to make the connections and to code this, and also we have learned the applications of this. So that's it for now. See you in the next video, robot builders.